Hi, everybody. Well, if you feel like this is a little bit improvised, it's because you're having a very good feeling. It's just what happens. I jumped in today. So I'll do my best, but I apologize in advance for any inconveniences. Under this QR code, you will find a repository where actually a better version of the code that I will show is available for you. With kind of running examples, a proper structure of the code as well. So we will be talking about Kubeflow pipelines, and we're going to try to dive into one particular problem that we face at work, and that we came up with a simple solution, in my opinion. It might be a little bit imperfect. I'm curious to hear your opinions on that as well, but yeah, let's dive in. So just hands up, how many people here have some experience of contact to Kubeflow pipelines? Or Kubeflow, more or less? Kubeflow? How many of you have heard the word Kubeflow in your life? Okay, that's right. And UV? Okay, I know, just to have a rough idea. So, Kubeflow, maybe I can jump already to this. Kubeflow is kind of an umbrella project that hosts many other kind of sub-projects. One of those sub-projects is Kubeflow pipelines. And the part Kube, as you might imagine, is related to Kubernetes, because this whole framework is sort of oriented to be, to have pieces that run well on Kubernetes. And yeah, so it's kind of designed with Kubernetes in mind as kind of an engine or as a support where it runs. And pipelines is one particular sub-project where that it's basically devoted to stitching together workflows, kind of ETL kind of things, but also machine learning training, machine learning serving, and all sorts of things. Just to make it a bit more concrete, like this will be, for example, a pipeline with 3 steps, or let's call them components from now on. The first component is one that downloads a data set. It passes some data to the next component that trains on that. Out of that training component come some predictions that we pass to the next component, and we plot something with that. So that's an example of a pipeline. When I say pipeline, I mean something like this, a graph of nodes passing data around kind of thing. So Kubeflow pipelines is kind of a framework that allows you to put together even very complex pipelines. Here, you don't need to know exactly what's going on in each of the steps. It's just to show you that pipelines can get very complicated. This one is, for example, one pipeline that we have in production for a couple of years, for which I actually implemented this solution first. They mean the solution that I will show you later, where I used UV. And yeah, and in this pipeline there are lots of things going on. So we load some configs, we train some machine learning model that trains for several hours, like in this case is a neural network. We output the artifacts of that training, like for example, the best checkpoint, something like that. With that, we prepare a new endpoint that serves predictions coming from this new trained model. At that point, we use sort of, maybe you can see my mouse. Well, no, it doesn't matter. The point is, then we prepare a test data set that we use to compare predictions coming from the new model versus the old model, the model that is in production already, and then we decide what if we need to deploy the new model. The usual stuff, like the ML ops type of thing that, well, you kind of orchestrate different kinds of steps. The nice thing about this framework is that it allows you to express these things in a first off, offering with a Python SDK, and also in a kind of intuitive and idiomatic way. So for Python is a framework to build this kind of these kinds of workflows. So we're going to look at one of those workflows now and to try to see how they look in code. First off, there are several kind of flavors on how you build each of these components. For example, you can write a very simple Python function and then tell the framework, hey, this is a component. Or you can write your own Docker file and build an image, push it to some registry, and then just tell the component, hey, use this container image and run this command, and that's it. So there are different flavors, but we're going to look at one of them, which is using Python functions, because they're quite handy and they allow you to iterate very quickly and to run experiments. To put very fast, to quickly put together pipelines that allow you to experiment with things. So I will unshare there and show you a bit of code that comes from a blog post I wrote a while ago. But the basic idea of a pipeline, let me show you here, is, no, let me go to the code, right. So we're going to take a look first at a proto pipeline. Is the size big enough? Is the color code enough good, or should I go for something like, because I hate dark things too. Is that better? Yes? No? What do we do? I keep this one for a while, then we change to the other one, right? So this is just a Python script. I called it proto pipeline because this is not a pipeline that can run. And by the way, one of the advantages of this framework is that it's kind of infrastructure agnostic in a way. So you can run these pipelines on different hardware. I can run it locally. That's what we're going to try to do here if the internet connection is good enough. But you can also run it on, say, Vertex AI, like on Google Cloud or something like that. The one that I showed runs on Vertex AI. So in that case, for example, Google has another Python library that knows kind of how to speak to the tool or understand how this pipeline is configured, and yeah, you can run it on different hardware. So the basic idea here is you have a Python script. In this case, it's just plain Python, so to speaking. This code, I'm not even sure that actually runs. For now, I'm going to stop maybe my LSP because I'm not sure. It's just to kind of have an idea of what's going on. There is a function that fetches some data. By the way, for this example, kind of shamelessly taken an example from the scikit-learn documentation. So I have no idea what's going on with the data or the model. But anyways, there is a function here that downloads data by calling this fetch data function, if you see here. It will split the data, and then it will pass it along, kind of, right? Here, I return that thing. So the next component is expecting that. In this case, it's a dictionary, but we will see. And it's training a classifier with the trained model. It is generating some predictions on the test data set that we will use to kind of see how good our model is. And we'll return those predictions. And then the next function takes those predictions and plots something. Plots something, right? So basically, this is the idea of the pipeline. these are the 3 steps, right? So what we're going to see now is what we need to do, how we have to decorate, pun intended, this code for it to work on Kubeflow pipelines. So far, does it make sense? Are you following? Is there any kind of urgent questions you're gonna? All right. Yeah, so as you see, these 3 functions reflect the exact, I think, plot that we had here, right? That this is what we're going to implement. And so what we do when we run, when we prepare this code or when we express this code as a pipeline, is we use from this library called KFP for Kubeflow pipelines, they expose a domain-specific language, so some sort of hack around Python that allows us to express things that are useful in this context. So from that, we are going to use a so-called component and a so-called pipeline. That's kind of all for now. I mean, yeah. And the other thing that we are going to use here is, is this concept of an output and of an input. Right? So before we saw in the code that we were taking the kind of the return values from the previous function and just passing that. And what we want here is, is we have to kind of work around that. It doesn't quite work. So we use this output thing. So basically, this is how we express the pipeline. So for example, this is the function that we previously had. And as you saw here, there are no, there's no input. But now we're going to say, okay, you're going to have an output. So this function will not return anything. It will know how to handle with the output. And the other, the kind of the symmetric way it works for the other, which is like you say, hey, I will use this input. So with that, the only thing we're missing is the dependencies. And the important thing here is that when we have a pipeline like this is also one of the other nice things of this framework, is it is going to spin up a container behind the scenes for us for each of these steps. So each of these steps is a separate container, and it orchestrates the flow of artifacts between them. And so the nice thing about this syntax that we are looking at here is that we don't need to build the containers ourselves. Saying this is enough for the framework to go write a Docker file, build an image, and run a container. I mean, install these dependencies, run a container, and do the stitching together of the components. That's kind of the magic behind the framework, right? So how does the code actually look like? Well, this was our kind of proto pipeline. So now we're going to look at the pipeline, but maybe I should, as promised, go with the other one. So this is the pipeline, but now wrapped in for the framework. So we decorate that as a pipeline, and we will have components. So for example, the download data component here is decorated with this decorator that's called custom component. We will see why. And the code remains more or less the same. The only thing that we need now is to basically have an indirection, which is instead of returning the output, we're going to write that to a file. And the library will take care for us of managing the path like managing the file system wherever we're running. If it's on my laptop, if it's on the cloud, it will be in a bucket or something like that, right? So that's basically the idea. So this is how we kind of write the function in a way that the framework understands. Yeah, then we see, for example, another component, which is basically the same code that you just saw, but again, now we read the data from a file instead of taking the input, and we write the data to an output. And that's it. So then we put that to we put that together in a pipeline, and as you see, we will have this syntax here. The tasks will have attached an attribute that is outputs, or it's always like that, and it's like a dictionary. Under the key data set, there will be a path to the proper place. And as you see here, this is also the nice thing that I want to show you, that you can run this pipeline locally. So that's what we're going to do here to see how it looks like. So in this case, I'm using UV, so I can just go UV run pipeline, and this is going to build a container image for each of the steps. Here it's running the task download data set. In this case, it found the image on my computer because I already ran it before, and it's behind the scenes setting up things like installing the dependencies we told it to install, and running the computations and writing out the outputs just the way we specified before. So while that runs, let me show you something else because we are a bit short on time, which is that as you see here, these dependencies, we have to explicitly kind of like manually pass them. And as you might imagine or not, this is kind of difficult to maintain because there are, first off, all sorts of incompatibilities between libraries and between transitive dependencies of those libraries, things that depend on these libraries. Also, for example, if you have this code in GitHub and you have something like Dependabot that looks at log files and dependencies like pyproject.toml files, it will not understand. And so, for example, if there is a security issue, I mean, Dependabot is a kind of a system that is able to automatically bump dependencies to fix security issues, and for free then for you. But if you do it like this, you will not have that. So the idea is like, hey, how can we bring these two worlds together? So how can we manage these dependencies in a way that is more sustainable and that adheres in a way to all the best practices that we know from dependency management in general, like having a pyproject.toml file, having a lock file that actually locks all the transitive dependencies and so on. So that's what I will try to show now. Yeah, so the first component is, it's done. As you see here, success. The second one is also done with success code. So now we're going to see what that looks like. And while that runs, then let me show you what we do to actually integrate the pyproject.toml or the UV, but it can work with poetry as well. That doesn't matter. It's like the dependency manager workflow with this thing that is kind of embedded in the DSL, in this domain-specific language, that we pass the dependencies like that. And what we're basically going to do in a nutshell is resolve these dependencies dynamically and by exporting them from the log file. So each time we generate this function definition, the runtime is going to go out, call, and try to get all the dependencies from UV, so a whole tree of dependencies, and pass that as a list here. So that way, we're going to have a pyproject.toml and a log file, so things like Dependabot will work, and we can still have this easy, quote-unquote, syntax that is kind of handy to work with. So this is basically what we're going to do. we're going to add a tweak to this component decorator. And the tweak is going to be this function, which is basically going out and calling on a sub-process UV. It's saying, hey, UV, please export the dependencies for this group. And the group is going to correspond to a component of the pipeline. So we will have for each component of the pipeline a so-called dependency group in our pyproject.toml. And we're going to resolve them when kind of at runtime in the sense of when we generate the pipeline definition. And so basically that's what's doing the trick. If you want to kind of jump a little bit into the definition, what we're doing here is basically we are taking the original component and we are writing a wrapper around that fixes one image, so we don't have to specify for each component a Python image. And the package to install is a call to this function that I just showed you that actually goes on calling on the sub-process to UV, grabs the dependencies, puts them in a list, and passes them along. So when we define the pipeline, we're not going to be passing only these dependencies, right? We are going to be passing a whole tree of dependencies to this list. And these will be installed inside the container, and everything will be tied in a way. So that's basically how that works. And let me show you one more thing. So basically, this is how it will look like in the end, which is the thing that we're actually already running in the background. And the way we modified the the component decorator is such that the original still works, so you can still pass other arguments. There are some other arguments. And if you want to add a new component, it very kind of naturally integrates with the workflow that we already have for UV. You go say, hey, UV, add a group, and I have a component name, and pass these dependencies, and then UV will go on and modify the pyproject.toml file for us, and we'll create something like this, right? Today I also learned from Francesco that if you have shared dependencies, like for example, these here are the same, you can actually have them like, for example, as a group that is called common, and under each of these dependencies you can say, hey, include the common dependencies, so you don't have to repeat yourself here. So that's basically the workflow I wanted to show you. As you see here, everything went through, and the local output here has all the pipeline runs, and for example, the last one is this 114, right? So for each component, there is a directory. That's kind of also one of the niceties of the framework. It generates everything for us. And as you see, the outputs are there, right? So for example, if I, time is running, but I'm not sure if I will be able to plot. Yeah. Anyways, by the way, I think you got the point. I want to show you something else before the time is over. So. Yeah, but just to show you the, yeah, that's how the there you go, how the final output looks like, and yeah, and it will be basically kind of tidy here for us, and that's pretty much it. Any questions? Again, go to the repo that is here, and I'll be around. You can ask me, we can talk, and if you have a better way to do this, I'm happy to hear you about your solution. So thank you very much.
Thanks for the talk, and we have several questions. So let me go one by one. So first one is, are Kubeflow pipeline fast enough for inference?
Yes, so what you do is, like, the whole pipeline doesn't run at inference time. It runs at train time, so to speak, like it runs offline at some point in time. And for example, one of these things here is creating an endpoint. And this endpoint is a container. You can have anything you want. So the short answer is that how fast the pipeline is, it doesn't matter for inference time, because on inference time you will have your own container running, right?
Yeah. Second one is, have you considered contributing the dependency resolution directly to Kubeflow? I realize not everyone uses VB, but perhaps this could be the start of a general solution.
Yeah, could be. I don't know. Yeah. Maybe.
Maybe the occasional.
I'm not sure exactly how. Like, they basically don't deal with the dependency resolution. That's why they just say, okay, give me a list of packages, I will install anything. And if you look at, like, under the hood what these pipelines are doing, it's kind of scary in a way, but what they do is basically, let me see if I can manage to see one output. JSON. Yeah, I don't have one here, but this will basically, it's called compile, it will express this whole code in JSON or in YAML. It will write one string, like it will be a serializable thing that will then just be uploaded. So, yeah, the short answer is I'm not sure that they want to deal with that. It's like, okay, you just tell me what I install and I do it. Yeah.
Thanks. The last one is, could you compare Kubeflow with Airflow?
Yes, I mean, they are kind of in a similar space in a way. I'm not sure I can give you a kind of a bullet point of list of pros and cons, but it's kind of a DAG orchestrating tool in a way. It goes a bit beyond in the sense, I'm not sure if beyond, but it integrates, for example, nicely with some platforms like Vertex AI. But again, I'm not sure I can give a very good pros and cons here. Like it's the same family kind of tools. Yeah, orchestrating DAGs of container jobs. I guess that's the best answer. I'm not sure. Yeah.
I think that's gonna be enough. Or if you have some further question, you can always come to speaker. And thanks for joining again for the last session or so speaker. And if you want to join the closing session, it's happening again at 3:10 at Kubasa, right? Yeah.